Good afternoon, ladies and gentlemen. Myself, Girish Sharma. We are going to talk about some of the best practices in enterprise Java monitoring. I'm a manager in Capgemini based out of Atlanta office, and I actually lead a sustainment team that looks after the production and some other critical environments. My focus is building a monitoring framework that could ensure a much higher uptime for the business and ensure a much stable system. Mangesh is going to start, and then I'm going to join him more.
Yeah, hi. My name is Mangesh Patil. If those on the back can hear me, just let me know. I'll try to pull it closer. I'm a senior manager from Capgemini. I am part of the enterprise architecture stream of North America. I work with various clients with some focus on enterprise monitoring, application development, custom development, all the way to some package solutions in a delivery capacity and also in a more consulting capacity. So I think what we're going to generally talk about what our experience is in terms of what we have seen at various clients in terms of enterprise monitoring. And for a 30-minute session, it's a very broad topic, so we'll probably get focused. I mean, I'm not going to stand here and pretend to know everything about monitoring. So I'm going to mostly focus on what we have observed in the consulting capacity, and then we probably try to have an open dialogue as to what your experiences and we can share some of those. I live in Raleigh, North Carolina. Anyone else from Raleigh, North Carolina? Well, excellent. So I'm also a TOGAF 9 certified practitioner for enterprise architecture. And we have our own tailored enterprise architecture framework in Capgemini. It's called Integrated Architecture Framework. It's a blend of TOGAF 9 and Zachman to a certain extent, a more practical approach to that. So I think if some of you are familiar with Zachman, I think you will see a glimpse of that in the agenda. We're going to approach this problem, the flow of the discussion. We'll talk about why monitoring is important at an enterprise level. Then we'll slowly move on to what is it that we need to monitor. We'll also talk about how do we monitor in terms of some of the patterns where we can make it really, make it operational. There is one topic that usually naturally flows next to that is with what, and these are where the tools come into picture. Unfortunately, in this forum, I'm going to not try to refer to any specific tools because I'm not in a position where I can endorse a particular tool in this forum or even to be criticized something. So I would mostly be staying abstract. I'll still cover the content, but without reference to, and even if I refer to some of the specific tools, it would be more from an example point of view. And I've seen there are some mind-blowing demonstrations I've been to up at the exhibition, and there's some really good tools out there you should look at. So why monitoring? And I think before I get started, I think I just want to get a pulse of the crowd. So how many of you are from engineering or hardcore design and development background? Okay, and how many more into management, leadership, and sales functions?
Got the right audience.
Okay, so I'll probably get then a little bit deeper into the technical side of it, and feel free to get engaged in the dialogue. So in the beginning, when I thought about, okay, why monitoring, I feel like, it would be preaching to the choir, especially with this audience who's been through it. But then I'm going to go ahead and make a contradictory statement that we still are not as much focused on monitoring as we should be in today's world. In general, if you look at the IT spending and budget for the IT support operations, there is not much that is given for building a monitoring solution versus how much we spend on in a reactive mode. When the problems happen, we have army of teams supporting it and doing the incident management. So the better we get at monitoring, we should be able to cut down on the staff that we need to be in a reactive mode and be able to do a lot of things in building intelligent solutions that can proactively deal with those things. Now here I'm just going to make a statement that if I look at the spectrum of the monitoring systems that are out there today, information systems, a water heater is much more sophisticated than what we have out there. And just to flow with the example, so a water heater is it's a simple thermodynamic system. Now you get hot water, cold water, put it together. In the simplest form, all you would do is you put your toe in the water and you see how lukewarm is it, and is that what you want? You get burned in the process, and I think our monitoring systems are right there at this state. We have a process where we have all kind of fancy dashboards and workflows and all those things that are put up by the tools, and then there is a human intervention required, that you read those things, you analyze, and then you come back, and like you would adjust the tap water, you come back and you adjust you tune your systems, and you react to the problem. A water heater is much more sophisticated because it has a negative feedback loop. It has a thermostat, maybe some kind of transducer that feeds back into the potentiometer that controls the flow. So it's automated. The way it reacts to the problem is automated. I can't think of many systems that are out there that can react to the problems like that. On top of that, it's even more sophisticated in terms of it has a solution to monitor the monitor, which is the fuse. So in a thermostat, you basically have a fuse, and if things go out of control with whatever your feedback loop is, the switch just switches off, and it takes down the part of the system that just goes down by itself and doesn't burn down the house. If you relate that to an information system, you really need a solution like that that can isolate a component that is likely to fail and just bring it down, give time to recover, but then try to keep your business up and running with minimal cost of downtime. Now, well, I think I'm going to slowly get into more technical problems and why monitoring, rather than explaining those things or than the first example. I'm just going to take some sample problems that we have faced that could have been avoided if we had a good monitoring solution in place. So those who are familiar with looking at Java systems and looking at how to interpret data, can someone tell me what does this look like? A memory leak. So this is the time when somebody shouts out, shoot the developer, because Java is not supposed to have memory leaks. But it happens. Now in this case, what's interesting is it's not the developer's fault, because you can still have memory leaks if the developer does his best. There are some things, even at the API level, Java programming language has something nasty called as soft references. For those who are not familiar with the terms, I think we have hard, weak, and soft references. Particularly the soft references are the ones where the JVM doesn't react until it is about to throw out of memory exception. So there is going to be a point in time, and this is kind of exaggerated just to kind of fit it on the real estate I have on one page. But usually you have these things accumulated over a day or something, where your JVM starts operating in a very narrow band of heat. So now it's all legit. The code is legitimate. But it comes to a point where there is going to be a period of about an hour or even more than that while you have that narrow band, and before the JVM does the major garbage collection, collecting the soft references, you're going to see some slowdown, which is going to reflect on the user experience. If you have a system which, like the feedback loop I talked about, it can actually check the JVM health natively and react to the problem. It could just recycle the JVM if you have a redundant JVMs built in. And there are some good solutions out there. I think one of the ones I would like to mention is I recently had opportunity to work with IBM's virtualized enterprise. It's an extension of WebSphere ND, where they have a smart on-demand router in place which can actually detect a JVM which is going into bad health and just shut it down, recycle it, give time to recover. But that's a smart way of reacting to the problem. But if you don't have anything in place, you're going to have some user experience that's not going to be liked. So the first one that we saw, this is more to do with the performance problems, how you can get into performance problems if you don't have a place to know what's going on in the system. So this one, I think, take a few minutes to kind of go through this. this is a coding. So this is a place where you should really shoot the developer. That and it's simplistic. You have a simple system with the application and the database. You have a field defined in the database, a primary column, which is a 5-digit number, and then you have a disconnected corresponding Java field, which is a long, which can hold much more. And then you have an independent identity generation mechanism, which can fit into those identities, which eventually get persisted. These three things are disconnected from each other, and usually, a lot of times I've seen the identity generator is pulled into memory so that you can be fast in getting those IDs. You don't have to go back and forth between the databases to tell you what is the next value. A good solution, but if you don't do the due diligence in this, you're going to be in a situation where you are going to overrun your max value. And think about it, that if you have a retailer system and if this is your order table, you're going to have an outage in the system, period. Now, well, we developers are, the community, we're smart. I think we do bugs, but we don't keep it so simple for people to figure out easily. So we make it even more complicated. What we do is we have some sort of rolling mechanism. When you reach the highest value, we introduce some kind of purge process so that all those old numbers that are out there, you try to get rid of those, and then you start afresh. But then somewhere down the line, you're going to have a foreign key constraint violation, and you're going to still hit the roadblock. Now, if these things are not monitored at the design level, it might look very well on the whiteboard. It might still work. But in reality, in Murphy's world, you will have problems with this. So this is, if you have a situation like this, and maybe this is not the best solution. I mean, you might argue that why would you design or why would you do it like this in the first place? There are various reasons. Sometimes it's out of your control. Sometimes we live in the world of perpetual beta, where business wants you to put something quick and dirty out there. Doesn't matter, as long as they can run, they can get revenues that they want. So you will have situations like this, and you will have to be able to react to those. Well, here is an example of what could happen with respect to security if you don't monitor it. So here is a typical system where you're using a one-way hashing function, and it's a very popular mechanism when you deal with password validation. So the use case is simply you're storing a password, you do a one-way hash function, you store the hashed value in the database. When you come back to validate, you take the new value, you generate the hash value, and there's a one-to-one mapping with that, and you validate it. Ideally, it works fine with passwords. The problem here is where this is a case where you should shoot the designer to design this, not the one-way hash function, but the way of doing the security with the 4-digit PIN number, where this doesn't make sense. So the problem with this is open to a brute force attack. You can do a dictionary attack where you have a 4-digit PIN. There are only finite number of combinations. So all your data, all the ports are locked. The storage is locked. The data is secure in storage. The data is secure in transit. From a security compliance perspective, you're good. But then somebody sitting outside knows that this is a 4-digit password, and from that to that is only about 9,000 combinations. So you can just run a loop and hack it. So this is something. Now sometimes you will have a situation like this. You will have a solution like this in place, and you will realize once you put it in production, you don't have much time to build another one. So you need to have a good monitoring practice to monitor the ports and see if there is somebody who's trying to do this. So I think rather than trying to explain it, I just want to take some examples, just so that we realize that we could have avoided these problems. And sometimes you will be facing these problems, you like it or not. We'll move on to the second topic, that is what to monitor. And I think, like I said before, the threats are specific to your system. Everything doesn't apply to everyone. So I've just categorized some of these general risks that are out there. Not necessarily they apply to all the systems. The first one out there are related to the system availability, something that has software or hardware components going down, also performing badly. And I think Girish will come back to those later when we talk about the metrics, about what needs to be monitored in those. What I've listed as a time bomb, and that is the maximum value counters, the one that I showed earlier with the identity, is a time bomb sitting in the system. It's going to explode someday. You have memory leaks, scalability issues in terms of if you don't do your load projections very well, you're going to run over the capacity, so you need to know that ahead of time. And then there are other capacity metrics, which Girish will cover later. Security threats. Now, this is a much broader topic, and I think I'm not an expert on security, so I've just listed what I'm familiar with. Usually, I've looked at two ways of looking at the security. One is the external attack, what you're exposed to the outside world, and one is the man in the house that can do some of the damage in terms of hacking into your authorization, authentication process, putting sniffers where they have access to. The outside attacks, there are a lot of techniques, and I think one page is not enough to list all of those, but cross-scripting or impersonation, Trojans, these are some of the common ones. And I think a lot of good monitoring tools, especially with security, already have figured those out, and they have a solution in place to work with those. In recent times, there is another one that I've seen trending is reputation threats. So the system availability threats are applicable to the systems who are more traffic-driven, where you were expected to lose a lot of revenue even if your system goes down for a little bit. Security threats apply more to businesses with compliance and sensitive data. We have enterprises and organizations that are very, some of them are very brand value conscious, and for them, the reputation threats are important. So especially the social media, there is a lot that is out there that can work against you if you don't know what's going on and what's the perception of your business outside. And I think there are some good tools that are out there that can actually index and rank a social opinion about what your business is like. And I think that's one of the good things that you should monitor as to know what's the perception of your business outside. Now, when I'm covering what to monitor, I'll slowly go into some of the best practices and some of the pitfalls also that we have seen in the past, and we'll talk at more details on each of those. So what makes a good monitoring solution? So we just looked at the whole, the works about monitoring. There are so many things that could be monitored. A lot of times what I've seen people doing is they just go out there, they buy a tool. Sometimes the tool comes in a big bundle package with promises from the salespeople that they'll do the job, they'll do whatever you need, and you buy the tool. It's a pretty big investment, and then you realize that you are forced to tone your monitoring needs based on what the tool has to offer. So in reality, what happens is you start monitoring what the tool has to offer, not what is it that you should have really monitored. So we just looked at the examples before that some systems are more focused on the outage and the downtime. Some systems are more focused on security. And maybe you may not find one tool that works for all. Sometimes it's the ecosystem that you have to build, and you have to put an integrated solution around it. So what we usually advise our clients is don't look at the tools first. Look at your threats. Look at what risks you are seeing. So one of the risks, the example that I showed you, you know that you have a bad solution out there in production running. That's a risk, and that's something that you need to monitor because you know there is a loophole. Sometimes you have a very robust solution. You have a lot of redundancy built into systems that even if you monitor and something fails, there is nothing much to lose. So you should prioritize and you should focus. Identify what your needs are, itemize them, and then go shopping for the tools. The second part is about the view that the monitoring tools have to provide. Most of the tools that I have seen, and there are some really fancy tools out there. I think I looked at one over on Moscone at the Oracle where you can literally see the flow of information and connections like you could see like a hydraulic system. You know, it kind of shows you that view that you can start visualizing. But the problem with most of the tools that I've seen is that they're very system-centric. They show you the views of JVMs, they show you connections, they show you nodes, they show you virtual machines, they show you load balancers. What they don't show you is a business-centric view of what you're monitoring. And that's really what is important, because from the time something fails till the time you report it to the stakeholders, if you go back and tell your business partner that I have a JVM down, and they're like, okay, so what does it mean? What they really need to know is I have a JVM down and I'm not going to be able to take orders in this specific product for next 5 hours. So that's what you need to have, that you need to have a tools or a set of tools or a general solution. It doesn't have to be a set of tools. It needs to be, it could be a blend of a custom and some sort of off-the-shelf products where you're going to be able to create a business-centric view of what you need to monitor. So if you're a customer-focused application, then you should be able to group attributes and metrics, what you monitor, by customers. Or if you are if you're a marketing agency and if different market segments is what you need to know about, then you should be able to group your system components at that level. So what should really come out of that solution is a business level view of what you're monitoring. So in terms of, and we talked about this proactive and reactive before, usually we have seen this situation where the monitoring tools have, they're more focused on the proactive mode, so they'll send you alerts. So what happens usually is they will have some kind of out-of-the-box probes, which will just show alerts and emails to people that are on the support. And they'll forward it to somebody else, and it goes to the whole 9 yards of the support system. And then when those people get engaged, they start all over by looking at the logs, looking at all the information, querying the databases. And that's what actually these monitoring tools should have done. Once you know what the problem is, once you have a sample, once you have enough information, the monitoring solution should launch into a more reactive mode, so that whoever comes in to fix the problem knows where to start. They shouldn't have to start over. So there should be capability in your solution so that you can identify an incident and you should be able to group the data that can launch into the investigation. So the next attribute of a good monitoring solution is establishing fault chains. This is one area where the tools cannot help you. It's your enterprise that needs to work on this. So fault chains are basically something that relate your system components to the business functions. This is mostly a set of documentation or set of dashboards that can tell you when you look at a business function, this is how it flows down the line. And when one of the components is down, this is what is going to get impacted. You don't want to figure those things out at real time. You should have done the analysis. You should have the documentation or something that takes you from a system failure into the business failure. Now that's the runtime. But even at the design time, when you're building your monitoring strategy, when you're identifying your threats, the fault chains, they help you identifying what is redundant and what are your single points of failures. Sometimes I've seen that very knife-looking components. Like if you think of, let's say, a load balancer that you wouldn't sometimes even have in your testing environment. Maybe you might be just running on a single JVM, single node. You will take care of your functionality. It will work. When you go to production, you scale up. You have all these other components that get placed in, and they are the ones that fail because they don't get tested in the testing many times. If you have the fault chains in place that show the landscape of your production systems, you would have realized those upfront, and you would have been able to put a solution around them. Now we just talked about the single point of failures. Particularly, this is very important. I think in today's world, we don't have many. I think the technology is advanced enough that you have redundancy in almost everything. You have, especially if you look at Oracle RAC, for example, there is a redundancy in database nodes. JVMs, you have horizontally scaling clusters. One JVM going down is not a big deal anymore. So, but sometimes, by design, you're forced to have single points of failures. And one of them I've seen very often is in the messaging frameworks. Messaging frameworks, the order of events or order of messages is important. And to be able to maintain that order, sometimes you can't really have the redundancy that you need because you don't want. So let's say if you have an order that you create an order, and if you cancel an order, you don't want cancel to go before the create. So by design, there are single point of failures that get introduced in your system. those are the ones that should pop out of your fault chains, and those are the ones that you should focus on monitoring. Now, the next topic I'm going to talk about, and I think I have a few more slides on this, that's more so in the modern service-oriented systems, the correlation. So what we have seen over the last couple of years is we used to have these monolithic systems in the past. They were simple. I mean, they were complicated to maintain and modify and enhance, but they were simple to monitor because everything that you need, presentation layer, business logic, data access, was all in one place. You could put it all together and make sense out of it. Now, when we go into the service-oriented architecture, things get much more distributed and much more disconnected. So that's where you need to establish something, and I have some diagrams I'll show you later on. I think we can jump right into this. So this is a typical view of what a modern enterprise system looks like, which is going service-oriented. You have a number of presentation layer components or systems, number of applications supporting them. You may have a sophisticated ESB in the middle. You can have some domain services talking to the data stores. You can have some CEP components. You can have some batch processes and daemons that run in the background without a human intervention. You can also have some sort of package solutions that you interact with. There's a lot of diversity. Now, I'm just taking an example here that a user's interaction, a single quantum of interaction, a button click, that usually splits into 50 or 20 different synchronous, asynchronous calls that flow back and forth between services and components. They're usually disconnected. If you look at your logs, if you look at your monitoring solutions individually, there is no way you can figure out what the hell is in terms of what the business is, what the user is trying to do. And then, now that's just single user click that we talked about that flows across services, goes into external systems, has some external clients involved. Now you talk about a workflow. So when you're looking at an order processing, I'm just taking that as an example, there is a unit of work that the end user is trying to do. And you need to put some sort of semantic, and there are different ways. It depends on what your enterprise is about and what your business is about. But there needs to be a semantic that you need to define at the enterprise level as to how all the messages, they get correlated. What is it that they get grouped by? In this simple case, it's a button click, and I'm saying, okay, it's a click ID. You generate a GUID, assign it, let it flow wherever the message flows. So when all those things get logged or when they get monitored, you know that they're all related. You can correlate, aggregate these, and make a business level sense out of them. Workflow ID or a use case ID. And a single button click is very atomic, but usually you talk in terms of what is it that the end user is trying to do. Are they trying to purchase something? Are they just searching? Are they doing a payment? So these are the semantic that you can build, which is applicable to your business. And I think these are some of the techniques of how do you do the transportation and analysis of those. So this is a horizontal view of how the messages or how the calls flow from end users all the way to the database. You would see that they go from a client application, and you will have a lot of HTTP mediation, other transportation mediations that will sit in the middle. They will have their own proprietary ways of logging, monitoring. It will flow into a JVM or some kind of business logic, application logic. It might not be one, it might be a multitude of those. Might flow into one or more databases. So how do you transport? How do you propagate that context information that you just generated? So there are various ways, and I think I'm imagining over a period things will be more flattened out, either using HTTP. We also have JMS in some cases. I haven't seen very many standardized APIs as to how you propagate the context, but that's something probably we might need to move forward as an industry level. If you're transporting HTTP, and a typical way of doing that is you might be doing RESTful service calls or SOAP-based service calls. It's really simple enough to stick something in the HTTP headers. Most of the HTTP mediation components have capabilities to log them and monitor them and use those. For SOAP-based, you can put it in the SOAP headers. I personally feel HTTP headers are more important because a lot of these middle components don't have visibility into your body, which is where the soap header is. So I think I favor HTTP headers personally. If you're still old school, you still use ORB, RMI type of methods, you might have to go out of the way. You might just have to overload your methods with some of these as at a predefined position, or you can define your transfer object structures that they can inherit these properties from somewhere. When it goes into in-memory, now what happens is one of the web container threads is going to pick up whatever the call that was received. It's going to make calls into other multiple components. If it is in the same JVM, it can do some parallel processing. It can spawn off other child threads. But a thread ID is something that is unique when your message flows between components inside your application. So either you can use the thread local, or you can build your own singletons where you can associate these context IDs when they enter in, store them with your thread ID, and when they exit, you get them back from those singletons, and then you propagate wherever they go next. Ideally, if you build this using some sort of AOP or cross-cutting technologies aspects, then it should be very transparent to your business logic. And this is something that should be done as soon as you receive the message before you hand it over to your business functionality. Databases, and this part is very tricky. I think I haven't seen very standardized solutions to this, but let me go back to this 1 second. And I think here is an example I wanted to show that there is a, let's say one day, one of the nodes of your databases just start showing a lot of disk arm utilization and goes down. Now you can have monitoring around the database. You can say, okay, this is the node that's going down, but you really don't know what is it that caused it, because that takes a lot of analysis. If you have this correlation in place, you can actually trace it back within a fraction of a second to what is the user event that caused it. To be able to do that, you should be able to take the information that is available in your database sessions or connections, try to map it back to the application, map it back to the end user activity. So there are one or two techniques that I'm familiar with. One is I think on the Oracle Type 4 drivers, you are able to set connection information so that the connection knows who's making the call, and you can set some context information on those. The other simple method is when you fire your SQLs, you can add a simple predicate where you say your context ID equal to context ID, which is harmless enough that bypasses most of your query processing. So doesn't add any latency into your queries. But still, when you look at the query in the database, you look your context ID right there in the query. So if your DBAs come back and report that this is the query that actually took the database down, you can immediately report it back to the business function that caused it. And I think, so these are some of the practices, and I know this doesn't cover a whole lot about everything about monitoring. These are some of the common problems, common patterns that we have seen as in our consulting work, and I think that's something we talked about. Girish will talk more about not exactly the tools, but what are the things to look at from the tools perspective when you go out shopping for those tools.
Thank you, Mangesh. So we talked about why monitor, what to monitor, and then the next question is monitor with what? What kind of tools to select? So what we are going to talk about is basically what to look for in tools when we are actually selecting the right tool. There are different factors that we actually want to monitor, and that all depends on your system. If your system requires some kind of if there are some availability threats, like the availability of the system is critical for you, like the hardware or the softwares or the time bombs in terms of running out of the counters or anything, that is something that basically you need to focus on. Capacity issue, essentially your CPUs, too much of load, bandwidth issue in terms of networks or pooled connections or all those, or the heap or the memory overruns. GC is doing, your JVM doing too many garbage collections on all those things. So important factor when selecting the tool is basically identifying your threats and the risks. Once you have identified your problem, saying what you need, then you can go back in the market and say, okay, what are the tools that helps address these issues? So now that you have identified your risks and the threats, what additional things to look for in that tool? Very important, rich UI. Because the developers are going to be looking at it, at a time when the time is of essence, there is immense pressure. Something that has a rich UI is very helpful. That should make, the debugging or the investigation very, very simple. You are kind of, working with it visually. There are tools that are available which actually runs in the JVM that collects a lot of data and then gives you all that information. But then that tool itself could cause your application to die. It could potentially kill it. So look for something that is not intrusive. There are tools available which actually have a lightweight agent running in your JVM that sends the data across to a enterprise server kind of thing, and then that enterprise server collects all the data and then analyzes that and then gives you another view so that you could create dashboards and things like that. That is preferred over the other one, but then again, that itself could have potential of bringing down your JVMs based on how much data you're collecting from each transactions. So there are products available which are like a huge bundle. You buy that one big product, it offers A to Z, 76 different things. Most of those you do not really need. Something to look for is basically an a la carte option. You could buy the base product and then add to it what specific you need. Things like specific interest in monitoring, whether it has to be a security threat or the availability part of it or what. Look for something that has open APIs, how it integrates into different applications. What are the alerting mechanisms, whether it has ability to hook up into your SMTP or send text or create a ticket that actually goes to the developer or a support engineer or whatever. So look for open APIs, because once you log in into a product, then anything that you want to interface with kind of comes at an additional cost. So once you have the data collected and your enterprise server who has actually consolidated all that data in terms of application monitoring, see how that same data could cater to different audience. You could have an audience that is right from your developer to your system administrators to your very high level business people. So the same data should be able to make sense for everybody. It should be able to provide you different views that you can cater to all different audiences. And again, there are different levels of tools that actually intercepts each and every transaction. There are different tools which actually only log or monitor a minimal level of transactions once it goes beyond a threshold. And then there are certain tools who do a sampling based thing. So something that does a sampling based, does not put a lot of load on your existing application, but at the same time, it does not guarantee that every single transaction or one of the transactions that has taken your system down has been captured by that tool. So identify what is more important for you. If it is that your system can take that additional load of monitoring every single transaction that comes in, or you could do a sampling based or something that basically creates or logs a minimal amount of compact data. Where to put the monitors? Now there are several places where you could actually plant all your sensors and cameras and saying, okay, this is where I want to monitor. One of the classic examples, as Mangesh mentioned, is like a inbound, outbound service interfaces. You could create a interceptor that basically once you get the request, you monitor that, the request goes out, you monitor that. There could be, outside watchdogs like the ESBs on all those that you could monitor. The logging monitors. A lot of these application servers actually create an immense amount of system and error logs, which has very valuable information. See for tools that could help you hook up into that information and search for something that is very specific, something that might give you errors or the cause of those errors, or systems going down, something like those. And the regular health monitors and the pattern analyzers. So those are the other two additional items that you could monitor. What are the general critical items to monitor? Everybody has web services these days, and some of the very basic and standard things to monitor in a web service is things like average response time, your throughput, your concurrency, things that are like hung threads, stall transactions, errors. If you see those patterns saying you are in a healthy running system, you get about 1 to 2 business kind of errors, but suddenly you start seeing tens and hundreds of errors within a short time, that is something that should basically alert you. You have asynchronous systems in place, and you talk to a socket client or you talk to a messaging application. Again, when you talk to a socket client, see how many socket connections are opened, how many socket connections are closed. The other system might not be responding, and anything that you basically monitor on the sockets should be able to alert you of any of those external system downtimes. And then there are additional, miscellaneous items that you could monitor, right from your disk space usage, things where usually your JVM would create some kind of dumps, or when it crashes, it kind of creates some thread dumps, heap dumps, and it puts those there. Look for thresholds, basically. Once it goes beyond a certain point, then that is something that should alert you, saying your system has crashed and recovered by itself. Things like WebSphere VE, it has ability to start a new JVM once one of those JVMs actually crashes, and take that out in a maintenance mode and things like that. So there is some level of automation, feedback monitoring built in some of those systems, but then your monitoring should be able to take advantage of those and go back in time and say, okay, one of my JVMs actually crashed and restarted. Let me go back and look into those heap dumps. So the alerts would actually tell that one of those incidents has actually happened. Your disk arm utilization, or your simple JVM heap, or the GC patterns, as we saw in the first example. The GC pattern should be able to tell you if there is any memory leak in your application or something like that. If you look at the overall budget spending in terms of an IT support organization, a very heavy focus is actually given to a reactive firefighting effort. There are huge teams. Looks like there is some overlay from the next slide, but forgive that. We are just looking at the pie chart. The one that in white could be ignored. So there is a huge focus on firefighting. Every module, every team has tens of developers supporting the application and looking at the logs and all those. There is some amount of focus on any enhancements that keep coming from the business, saying that's a continuous ongoing thing, and there is a very little focus on proactive monitoring. The moment we start diverting our focus to proactive monitoring, we would definitely see a huge shift in terms of how much time and money and effort we spend on reactive firefighting. Monitoring as part of the IT application supports. So in a given life cycle of software development life cycle, all the way from design development to go live production, release, support, and all those, there are several things that have matured over last several years or maybe decade. Monitoring is additional concept that has come in the last few years, and the software development lifecycle has not yet completely embraced it. Even until after we go live and have several mission critical applications in production, we still do not have a robust monitoring infrastructure in place. So that is one thing that the management, that is something that the stakeholders has to identify as a critical part of our development life cycle, and identify all those monitoring things right at the beginning when we are building the system, so that we put the right probes in place, so that we put the right sensors and cameras in place, so that when the application actually goes into production, we are able to support and sustain it better. I think that would be all. Any questions? I think this deck and the recording would be available on the Oracle website as part of the Java one. Yes, please.
Does the company by itself provide some monitoring tools or solutions?
Does
your company provide any monitoring tools?
We are
integrated solutions or consulting services?
Absolutely.
What is your interest in this area?
Okay, absolutely. So we have an expertise in understanding your requirements and kind of recommending you the right tool or the right set of tools, and help you build a solution and a monitoring infrastructure that would help you basically select the right tools and then put that in place, integrate that with your application, and then help your organization support that.
Can you name some clients of yours? Can you give some names, some company names?
Some company names of what?
Your clients, your customers, where you.
So I think that's one area I wouldn't necessarily get in. We can probably have an offline one-on-one session and we can talk about. But yeah, that's one thing we wouldn't necessarily want to know.
But there are several big clients who actually we are working with, where we have implemented these kind of monitoring frameworks and systems. Sure. All right. Thank you, gentlemen. Of course, ladies and gentlemen.
Thank you.